Jonathan and Ronnie from UI, and our our work is from very practical industry needs. Some of our clients, like the banks, really process hundreds, tens of form documents, application forms from their customers. Their customer just fill in the form and scan, send back to them for process and approval. So what they are doing is just to use apply the OCR upon these form images and try to get the text values from it, like the name, nationality, date of birth, whatsoever. One of the big problems they're facing is the form has a lot of artifacts, layout embedded in it, like the lines or the form cells, which is very, very annoying and cause a lot of problems for your OCR recognition error. So our tactic is basically to try to identify and remove these artifacts, like the lines and boxes. Here is our model. Basically, it follows a standard like UNITE framework. The UNITE framework is just encoding and decoding argument. The left part is the encoding part will take in the image and take some process, get the feature from the image, and the right hand part of it is just trying to recover the size of the final feature map consistent with the input image. In this way, you can do the pixel-wise classification, whether this pixel belongs to the artifacts or not. That is called segmentation. The only difference from the standard encoding decoding argument is the UNITE copies the feature map from the encoding side to the decoding side. In this way, it will maintain the resolution power, which is better to capture the mini structures, like the intersection part between the base character and your artifact lines. Just avoid some over erase. So this is our model, but in order to train the model, actually you need some label data if you want to go the supervised way. Of course, you can do everything manually and to color the lines or boxes by hand, but it is very time consuming, and what's more, it's error prone. And any handshake, you will mess up a lot of pixels there. So our work is to do it automatically with writing some code. The first step is we have extracted a bunch of thousands of lines and row boxes from the row forms. It's quite wide variety of styles. And then we write a code and automatically position these lines and boxes randomly over the base images, like this 0, 5. In this way, you can randomly get a bunch of large number of training data as much as you want. So with this data, you can train the unit and without any trouble. Here are some example of the DeepErase effect, and the first row and the third row actually are the input with a lot of artifacts like the spurious word or lines, boxes, and after processing by our model, you can see the artifacts are gone and everything is very clean. And this process actually in the end will enhance the recognition performance dramatically. We benchmark our model to the traditional Hofline method. Hofline is just a pure CV2 method to identify the line within the document. And as we can see, our lift on the recognition error accuracy is way better than the traditional way. So this is our work, and we have a more comprehensive testing results with on the some raw data NIST 06, NIST 02, both handwritten and printed. And we also have some other benchmark. Welcome to our poster and for some further discussion and new details. Yeah, thanks so much.